Hello, Stats class. Happy New Year to you. And here is lesson 6.3a. So, quick little intro. We've been doing random variables in a general form. We learned one special type, which was normal random variables. And this week is all about two more special types. So the first one is binomial random variables. And I'm about to tell you what that is. So you know what a random variable is. Binomial, you see the word bi in it, which means two. And in this case, it means two possible outcomes, which means we've got a success and a failure. A coin flip is a good example of that. Or there's many, many other possible things that could happen that would have successes and failures. Pretty much anything that has more categories than two could be grouped into two categories. And we'll do that with our example today. So there are four things that have to be true in order for it to be a binomial random variable. And so we're going to start with that, the four criteria or conditions for a random binomial random variable. The first one is the two possible outcomes, which is binary. Bi meaning two again. So yes, I realize I repeated myself, but that's okay. That's the first thing that has to be true, but it's not just that. The outcomes have to be independent, or in other words, each trial does not affect all the other trials. The third thing is the number of trials is fixed in advance. So if you're flipping coins, for instance, you decide in advance you're going to flip 3 times or 4 times or whatever it is you decide. And that's important because later in the week we're going to learn another type that does not have that particular condition. And then the fourth thing is closely related to the independence, but I'm going to say it anyway, and then I'll tell you why it's not the same as being independent. Success probability does not change with each trial. And two more things I want to say that I won't make you write down. The book gave me this. It spells BINS, which is a good way to remember it, BINS. There's another one that has a different acronym later, but that's the reason I put the word success first here instead of P for probability. So make it spell something cool. And then the other thing is, I just mentioned this, I used to think that maybe we didn't need the independent and the success probability doesn't change, because the reason that doesn't change is because it's independent. But then somebody gave me an example of one where it could be independent and the probability does change. So the example that I'm thinking of is if you have a quiz, like multiple choice quiz, and you're talking about the probability of getting 3 answers right out of 10 or something like that. If the multiple choice questions have different numbers of choices, then that would change the probability. So like, let's say number 1 has 4 choices and number 2 has 5 choices. That would change the probability even though they're independent of each other. So we want every single one of our trials or questions or whatever it is to be the same probability and independent of each other. So both of those are important. And if you have those 4 things true, then it's actually not very hard to figure out how to find the probabilities for a situation like that. So I'm going to do an example before I tell you the formula, because I want you to see that the formula is actually kind of common sense. And if you understand why the formula works, that will help you. So I'm going to do the example first and then come back to the writing the formula in just a minute. Let's do an example. Let's not do coins, because the problem with coins is that the probability of success is the same as the probability of failure. And I want one that's different, that where the probability of success is not 50%. So I'm going to do die rolls. We're going to pretend we're rolling a die. And we're going to say a success is defined as getting a 1 or a 2. And a failure is defined as getting a 3, 4, 5, or 6. And that success and failure can be defined however you need to for that specific situation. So it won't always be like this, but I'm choosing an example where these are not the same. It's not half and half, it's not odds and evens or anything like that. I want them to be different so we can talk about that. So this is officially the probability of success would be 2 chances out of 6, or 1/3. This number is traditionally called p, but that's a lowercase p. And here we got a picky detail. Lowercase p is just this probability of success. This is a capital P. So if you're talking about a probability of whatever and you're putting the event in parentheses, you use a capital P. If you're talking about, if you're trying to just label the number, it's a lowercase p, and that's picky, but it's important to me. So let's do it. Probability of failure, I hope, is obvious to you. There are 4 chances out of 6 that you could not win whatever game this is that we're playing, and that reduces to 2/3. And the tradition is to call this one Q. So it's P and Q. And Q is always 1 minus P. It's the complement of P, or they add up to 100%. Now, I'm going to say that now, and that's the first time you've seen that. I'm going to probably have to repeat myself many, many times for the rest of the year, because there's always somebody who, if I forget to say 1 minus P, they'll say, wait a minute, what's Q? And I'll have to say it again. So I'm going to keep saying it again until everybody's got it. The book doesn't even use the letter Q. They just always write 1 minus P. If you'd like that, that's fine. You can write 1 minus P in the formula. But I like to call it Q because it's so much shorter, laziness. Don't write 1 minus P when you can write Q. So anyway, they're called P and Q. The probability of success and the probability of failure are fixed. All right, so now I need a number of trials. I'm not going to just roll 1 die because that's boring. I'm going to do 4 rolls in a row. How many different ways could that come out? Now, I am not going to worry about whether it's a 1 or whether it's a 2. If I get a 1 or a 2, I'm going to call that a success, right? So I want you to just picture for a minute. You don't have to draw this, but picture if you were making a tree. You could go crazy and have 6 branches, right? And then have 6 more branches. I'm not going to do that. I'm not even going to draw the tree because I want you to just picture success or failure, and then another success or failure, and then another one, and then another one. Can you imagine it without me drawing it? I hope so, because what would happen is you have 2 choices and then doubling to get 4 choices, and then doubling and then doubling. It's 2 to the 4th different ways it could come out, or 16 different possibilities, which is why I'm not going to actually draw that tree. 16 possible ways it could come out. So it could come out success, failure, failure, success, or it could all of those different ones. There's 16 of them. I am not going to list all 16 of them because that's crazy. I'm only going to list the ones I'm interested in. So let's talk about specifically the probability of getting exactly 2 successes out of our 4 rolls. So we still have this picture of a tree in our heads that we don't want to draw, but we are going to think about which branches on that tree would give me 2 successes. So how many different ways are there to get 2 successes out of 4? This I'm willing to list because it's not so bad. So it could be success, success, failure, failure. If we were in class, I would be having people call out other possibilities to get 2 successes out of 4. I'm going to list them kind of systematically and say I could get success, success, fail, fail. I could get success, failure, success, failure. And I could get success, fail, fail, success. And that is all of the possibilities that have success first. So success first would be 1 branch of my tree. And then I could go success, fail, fail, or I could go fail, success. You could draw it if you want to, right? There's 3 of them. There's 3 more. And I hope you realize that they all start with F. So failing first is another thing that could happen. And then that second one could be a fail, success, success. Or this failure could go anywhere in here, right? So it could go success, fail, success, or it could go success, success, fail. And that is basically all the possibilities. There are 6 ways this could happen. So there are 6 ways to get 2 out of 4 successes. And if you haven't learned this in another math class, I'll tell you that this is called combinations. In other words, we don't care which one of these we get, we just care that there's 2 successes. Combinations, permutations is if I cared which one it was, and then there'd be 6 that don't all count as the same thing, and I would care about each one separately. And when we're dealing with combinations, it doesn't matter which of these we get, but we have to know that there's 6 ways it could happen. So that is the number of different ways of choosing 2 things out of 4. Which is kind of what I just said, but that's another way of thinking about it. So if you don't know this from another class, I'm about to tell you. I'll tell you the formula, and then I'll tell you the calculator way because it's so much easier. The AP test calls it this, and some books call it that. Other books call it this. Ways of choosing 4 out of 2, so I would call this 4C2 or C42, either way. I've seen it written a few other ways, but those are the 2 most important. The way you figure it out, calculations, and like I said, you may have seen this in pre-calc or maybe algebra 2. I don't know if they cover it in algebra 2 right now, but what you do is you say the first one could be a success or a failure, and the second one could be a success or a failure, and the third one, and so on. That would be if I'm doing permutations, but then if I'm doing combinations, I multiply it by 2 times 1 times 2 times 1, and I'm not going to spend a lot of time talking about that actually, because you don't have to know this formula. It's 4 factorial. And you don't have to know this formula because your calculator has it built in. So I could do this, and I could do 12 divided by 2. I get 6. Oh, good. That makes me feel good because there's 6 ways that I listed. Here's how you do it on the calculator, which is what you need to know how to do. And I hope you have a TI 83 or 84, but if you don't, then you need to figure out how to do it on your calculator. Most calculators, at least the better ones, have it somewhere. It's in the math menu. Yeah, math menu under probability, and it's the 3rd one down, except I forgot I need to type my 4 first. So I'm going to go back and type 4 and then go to math probability. NCR is what they call it, and then the 2. So that's what it looks like on the calculator. Cool, it came out to be 6. So calculator, it's a thing that looks like NCR. It's in math probability menu. And we're not going to spend a lot of time. I mean, the purpose today is not to teach you how to do this. The purpose today is to teach you how to use this to find this. So that's where we're headed. I will say that N is the number of things you're choosing from, or the number of trials. So in this case, that was 4. And this is the number of things you're choosing, or in this case, the number of successes. In this case, it was 2. So the 2 is R and the 4 is N. Or our book calls it K and N. It doesn't really matter. All right, so now that you've got that rather than listing this, because sometimes the list is really long, you could always do something like this. If I asked you for the number 2 successes out of 10 or something like that, that's a huge long list and you don't want to do it, but your calculator can very easily do 10C2. So that's the kind of a shortcut to that. Back to the probability, because that's the interesting part. Probability of 2 out of 4. Pretty much anytime you see something like this, exactly this many out of this many, that should be your clue that we're doing binomial. And then you would check these criteria to make sure it really is binomial. So 2 out of 4 or 3 out of 10 or anything like that is going to be a binomial situation. And what you do is you take the number of ways it could happen times the probability of it happening. So the probability of getting this success right here is 1/3. I'm actually going to get more than 1 success. I'm going to get 2 successes. So there's 2 of those. And then the probability of failure, which is 2/3. And I'm going to get 2 of those also. So that's kind of logical, isn't it? I'm going to write it again with the C thing in there. It occurred to me that maybe I shouldn't have done 2 and 2 because that's going to make you think these numbers are always the same, which they are not. I'll do another example in a minute to make sure. So this thing, we've got the number of ways it could happen. Remember, trials and successes. So this is the number of ways. Number of ways it could happen times the probability of success, which is P. This is the probability of failure, which is Q. This is how many failures and how many successes, which really makes sense if you think about it. It is an application of the multiplication rule, saying that if we've got a success and then another success and then a failure and then another failure, we can multiply those probabilities together. And then because they could be in lots of different orders, we multiply by how many different orders that could be, how many different ways that could happen. So that's the logic behind this formula. You, of course, can type this in your calculator. Either type this or type this. I'll show you both just to make sure. So you could take the 6 times, I like to use parentheses for this because then it looks like a fraction. 6 times 1/3 squared times another fraction of 2/3 squared. And that is my probability of getting 2 successes out of 4 in this situation. 0.296 would round up to 30%. And then just a reminder that you could type it as 4, go in here and get the NCR, and then the 2, and then the 1/3 squared, and then the 2/3 squared. So that's just typing it all out with the combinations thing in there, and that gives you the same answer. Okay, so I'm going to do one more example after I write the formula, because I really want to do one that doesn't have a 2 and a 2. I want to do one that has just something different. So here's the binomial probability formula, which, by the way, is one of my favorite formulas. It has applications in algebra also, so some of you may have seen this formula before in pre-calc or algebra. I think they used to teach it in algebra 2 with our old book. I don't think we do it anymore, which is too bad, because, like I said, it's one of my favorites. So the probability of k successes out of n trials is, I'll use the notation that the book uses and the AP exam uses, and then I'll probably write it the other way also. So it is number of ways it could happen times the probability of success, number of successes, probability of, actually I'll write it their way first, probability of failures. Number of failures is just n minus k. Or some people prefer this notation, and I like it better with a Q. It's a little bit shorter that way. This formula works only if the 4 criteria are met. And that's bins. Put a big box around this. I'm going to do one more example and just make it a little bit faster than that one. So let's say that now we're still rolling dice, and now the success is getting a 6, and that means the probability is 1/6, and failure is any other number on top of the die. So 1, 2, 3, 4, 5 are all failures, and that would be a Q of 5, 6. And let's do a different number of rolls besides 4. Let's do, just for fun, let's do, oh gosh, I don't know, 5 rolls. And the probability of getting 3 successes out of 5. Because I want to choose an odd number so that you can see what happens when these don't match. Okay, so I'm going to do my probability is C. Okay, I have to think about how many rolls, 5. How many successes, 3. Right? And then I'm going to do this, and I'm going to take my probability of success, my number of successes, which is 3, probability of failure, number of failures, that's 5 minus 3. So basically this is saying I'm getting 3 successes, 2 failures, and this is how many different ways it could happen. And then I type that whole thing in my calculator. So I'm going to type 5C3 times 1/6 to the third. Notice that matches, always matches. Oops, I have to get out of my exponent. Not 1/656, that's q to the second. And that's only a 3% chance. So you'll do a lot of those in your homework, and then we'll do some more in the warm-up for 6-3B, and we'll continue using this formula, which is, like I said, one of my favorite formulas. And I'll tell you some more in the next notes.